Good evening, boys and girls and Stingray parents. This evening we're going to take equations and inequalities one step further. And that's exactly what we're going to do. We're going to do one-step equations. And we'll focus on adding and subtracting. Those are the operations that we'll be working with as we work through solving these equations. Just one step. We'll get into multi-step later. Boys and girls, let's take a look at one-step addition and subtraction equations and inequalities. We'll start with these two equations and then we'll do an inequality. The first thing you need to realize about an equation is we want to think of it as it's a mathematical statement that must be true, and it has a balance point. Okay, what's on the left must be equal mathematically to what's on the right. Now I know when you look at this, you see, well, there's two terms over here. This already looks unbalanced, okay? And I know it's kind of spread out. But mathematically, okay, the value or the quantity of this expression on the left must be equal to the quantity that's on the right. The same is true of the subtraction equation. We have x minus 10 is equal to 21. So the information must say, well, this we're subtracting. How when you subtract can it be equal? Well, you're going to see in a moment here. The value of this expression, the quantity, has to be equal to the value over here, which is 21 on the right side. What's on the left must be equal to the right. The same is true with any equation. What's on the left must be mathematically equal to what's on the right. And the way we solve this equation is we need to figure out what this variable y, and over here what variable, this variable x, what these variables must be equal to make this statement true. Okay, and how do we solve for the variable? Well, we have to isolate it. We want it to be all by itself on one side of the equal sign or equation, and we want to have all the numeric or the numbers on the other side. Okay, now keep in mind though, the left and right must be equal. So if we do something, if we take something away or we add or multiply to one side, we have to do the exact same thing to the other side. Otherwise, we're gonna tip the apple cart over, so to speak. We're gonna lose our balance. The left and the right won't be equal anymore. So if we want this y, this variable, to be isolated all by itself, we need to get rid of this 3. And how do we get rid of a 3 mathematically? Well, we have to subtract it. So I'm going to subtract the 3 from this side of the equation. But we want to keep things balanced, right? And we want to be fair. If we take 3 away from this side, we need to take 3 away from this side as well. Okay, now I know this looks like a really funky subtraction problem, and that's exactly what it is. Right now, at least that's how we're solving. Well, we know 3 minus 3 is 0. Okay, and I'm not even going to put a 0. I could put a 0 down there, but it's not necessary. So the 3's are gone over here, and then we need to bring down the y. I also need to bring down my equal sign, and now I need to figure out this. Well, 15 minus 3. Well, 5 minus 3 is 2. Then I bring the 1 down as 12. So this says y is equal to 12. Well, let's try plugging y into our original equation, and we'll evaluate to see if it's true. Well, let's see. Well, I'll bring down 3 plus y, but we're going to say y is equal to 12. 3 plus 12 is equal to 15. You know what? That's true. Look, 12 plus 3, we'll stack it, do it traditional way. 2 plus 3 is 5. Bring down the 1, 15. Yeah, this is a true statement. Okay, our balance beam, even though we subtracted from both sides, we subtracted the same thing, and we solve for y. Okay, y is equal to 12. Now let's try our subtraction equation over here. We have x minus 10 is equal to 21. We want to isolate the variable. We want to isolate x, get it all by itself. The problem is we have a minus 10 over here. Now how do we get rid of minus 10? Minus 10. What's the opposite of taking 10 away? We want to undo this. Well, the opposite of taking 10 away, isn't it giving 10? So we're going to add 10. And remember, this is our balance beam. We want to keep it balanced. What's on the left must be on the right. So if we add 10 to this side, and we don't want it to tip, mathematically, we need to add 10 to this side as well. Okay? So if we take away 10 but add 10, they neutralize each other. Whang, they're gone. And we can bring down our variable x. We also need to bring down our equal sign. Do we need to, we can put a 0 there, but it's a waste of time. Then over here we have 21 plus 10. 1 plus 0 is 1. 2 plus 1 is 3, 31. So x is equal to 31. Let's test it though. Let's test it. Let's evaluate. So we're going to substitute the x with 31. 31 minus 10. Yeah, the mathematicians, we know it's going to be 21. Let's stack it right over here. 31 minus 10. Okay, 1 minus 0 is 1. 3 minus 1 is 2. Yep, this is true. So our answer, our solution, is x is equal to 31. When x is equal to 31, this equation is true. It's trustworthy. Now let's try an inequality. Let me change the color. Let's try green. I like green. Okay. So here is going to be our inequality. Let's keep it simple. We're going to say, let's say w plus 3 is greater than 7. Okay, now see, this is an inequality. We're not saying both sides are equal, but we're saying what's on the left here has to be greater than what's on the right. But in order to solve an inequality, we have to treat it just like an equation. Okay, we have to keep things balanced. So let's black. So we want to isolate, remember our w, we want to isolate our variable. We want to get it all by itself on one side of our inequality, and we want all the number stuff to be on the other side of the inequality, or our greater than sign. So we have a 3 here, a pesky 3. How do we get rid of a pesky 3? We subtract it. And what we do to one side of the inequality, we must do to the other. What we do to the left, we must do to the right. So we take 3 away, bye-bye 3, it's gone. We are just left with a w. We bring down our greater than sign, and 7 minus 3 is 4. So w is greater than 4. Okay, now it doesn't say w is equal to 4, because if we were to go over here and plug it in, 4 plus 3, it's equal to 7. We don't want equal to be 7. Okay, this is a true statement. But we want to solve for this inequality. So that means w can be any value greater than 4. The neat thing about inequalities is there's more than one right answer. So that means w could equal what? It could equal 5, right? Let's see. Let's just go back here. 5 plus 3 is 8. 8 is greater than 7, so that'd be true. We could also say w is equal to 10. Okay? 10 plus 3 is 13. 13 is definitely greater than 7. We could say that w is 1,000,000. Okay, in fact, there is an infinite number of correct answers for what we can make w equal to. But the key thing is, what's the solution to the problem? The solution to the problem is w is anything greater than 4. Okay, and we solve it by treating it like an equation, but we have to remember that our solution, instead of having just one answer, we have a lot of answers that can make this true. But the answer is w is greater than 4. That is our singular answer. W can't be less than 4. It's got to be greater than 4. But we can plug a lot of values in for w to make this statement true. We'll practice inequalities and equations more.